Hi everyone, in this video I'm going to take you on virtual geological trip to Billefjorden Trough. We are in Svalbard, that is located around 1000 kilometers from North Pole, and our main focus will be on the outcrops located around the Pyramiden settlement in the biggest island of Svalbard, Spitsbergen. On the geological map, the interesting outcrops for us are colored with a green color that represents Carboniferous and Permian. And my name is Alexandra Smeraxikora. I work at the University Center in Svalbard, and this is how I usually look during those spring excursions on snowmobile. So this is Svalbard with the biggest island of Spitsbergen, and let's zoom in into its central part, which is the most interesting for us. And our trip begins in Longyearbyen, where the University Center in Svalbard is located. From there, we'll be traveling on a snow scooter. So we start from Unis, and we will heading east to Sassendalen, and then we'll cross the frozen Tempelfjorden, continue to Leibsdalen, and then further north and to the west towards Billefjorden, where stop 1 is located. So we stop in the frozen fjord, and on this image from Google Earth, we'll see that there are two main bays in the inner part of Billefjorden. Towards north is Petunia Bukta, and towards east is Adolf Bukta. There are also a few quite big valleys, which are we will be working around. That's from the north, it's Ragnardalen, Ebbadalen further south. There's a Kampestindalen, which also is called sometimes No Name Valley. And east we have Mimmerdalen, and in the mouth of Mimmerdalen, there's a pyramid and the settlement. So we usually stay at the hotel, which is located in this ghost town. There are no people living there except from the staff that works at the hotel, and there's of course a spirit of Lenin around. On this 3D image draped with aerial images, we can again see the main valleys of Ragnardalen, now in the central part of the image. Ebbadalen. We see also two big bays and Pyramid Mountain to the west, and we see the main faults that we will be looking at in a more detail later on during this excursion. So from the place where our stop is located in the middle of fjord, we can actually get an overview of entire basin. You will find out that the oldest rocks, metamorphic rocks, and the Devonian rocks are marked with pink and orange colors. The blue color that marks pre-rift Billefjorden group is draping these units. And then on top of that, we have the Synrift fill, which is represented by the different shades of green. So this is the panorama from our location. We see here west is on the left-hand side and east is on the right-hand side. And this overview is approximately 15 kilometers wide, and then we get quite high mountains actually. There's a Pyramiden which is almost 1000 meters, and the Gerfjellet which is over 1000 meters above sea level. We also see frozen, of course, Adolf Bukta and Petunia Bukta. And some of the buildings that belong to the Pyramiden. When we look at the outcrops, we have to be aware of recent slides that are developed in this area. They're marked with the shaded gray color, and they are located mainly in the eastern part. The oldest rocks we can see, it's a metamorphic basement located mainly in the eastern side. However, looking at the Pyramiden mountain from more a bird eye, we know that There are some outcrops, again in pink, of metamorphic basement exposed further north. On the Pyramiden mountain itself, we expect to have some metamorphic basement that was also reported in some of the Russian mining materials. However, there's no outcrop. The succession is covered with scree. The Devonian layers are exposed in the inner part of Nimerdalen, and we don't see them on the uppermost panorama. However, they are on the Pyramiden mountain, on this western slopes of Pyramiden mountain. Next in stratigraphy is Billefjorden group. These deposits are mainly sandstones and black coal and shale, and you find them as a very thin layer in the easternmost part of the basin. And of course, in Pyramiden, this coal has been mined by the Russians in the mine. And the thickest succession is actually located north of Pyramiden mountain, where you can find 4 different members that are forming the entire Billefjorden group. The Sand Rift deposits start with Huldberget Formation, which is from the distance quite visible due to its red color. And in the deep slope, in the eastern side of the basin, there's only one red-colored interval, which is actually the Huldberget Formation, and that covers the Billefjorden group. However, on the Pyramiden mountain, there are 2 intervals with the red color, and the lowermost is the Huldberget Formation, and the uppermost belong to Ebba-Dalen Formation. We also have an outcrop located further north, which is also north of Pyramiden mountain, which is also colored with in red. And on the map, firstly, we have mapped it as a tricolor fillet member. However, most likely it is actually Huldberget Formation. Ebba-Elva member is characterized by siliciclastic dominated deposition with some carbonates and evaporites, and they are usually gray to yellow sandstones that are exposed within this formation, and the most prominent yellow layer actually represents this member on the Pyramiden mountain. However, on the deep slope, we can see Ebba-Elva member located in the inner part of each of the valleys. There is no Ebba-Elva member along the master fault zone in Pyramiden, located further to the north than Pyramiden outcrops. Following, there is an interval which I called here tricolor Odell fillet member. So we know that tricolor is mainly made by a white gypsum and black carbonates, and it's very nicely visible on the deep slope in the eastern part of the basin. So all these nice stripes here, black and white, with some thinner red shale intervals, are tricolor fillet member. However, in the western part of the basin, this member interfingers with Odell fillet member that is formed mainly by alluvial sandstones and conglomerates, and these are here marked with the represented by quite a thick red layer that we can see from the distance. And actually, Odell fillet member is forming it's a main exposure, it's a main bulk of rock at the Pyramiden mountain. Again, similar to Ebba-Elva member, we don't see any outcrops of tricolor fillet member further north from Pyramiden mountain. And this outcrop, which we thought was tricolor Odell fillet member, it's mainly represented by red shale, so most likely it belongs to Huldberget Formation. Following up in the stratigraphy is the Minking fillet formation, and on the deep slope it looks quite similar to tricolor fillet member. It's shown, or it's exposed as a thick beds of black and gray carbonates with white gypsum. However, in contrast to tricolor violet member, this is much thicker bedded. So the beds are in few to tens of meters thick compared to tricolor violet formation when we will be talking about decimeters to meter scale of bedding. On the Pyramiden Mountain, the succession gray in color just below the top is actually forming. It actually is minking violet formation, and we see that there is very little gypsum in this position. Minking violet formation is marked here with this grayish green color. On the Pyramiden Mountain is forming the almost uppermost part, just below the cap, the top. And it also extends further north, and it's forming the main outcrops of this slope that is located just to the west of Petunia Bukta. And this is how it stretches on the geological map. And finally, at the end, we have Verticamen formation. This is the uppermost unit. It's cliff forming, therefore it didn't get any color because it's so nicely visible. And if you look at the uppermost panorama, you find it forming all the caps and tops of the mountains here, as well as the uppermost part, the cap on the Pyramiden Mountain itself. On the Pyramiden Mountain, however, we have some parts which we are not quite sure what are made of because they are mainly scree covered, so we can only guess or expect to have some stratigraphy due to interpolation of the stratigraphy which is located nearby. Now let's talk about faults. We have quite some faults in the Billefjorden Trough, and from the east there will be a Babren fault array that is actually exposed in the northern part of Adolfbukta, but also we can see some faults of a Babren fault array inside the inner part of the Ebbadalen and Ragnardalen. In the zoom-in pictures, you will find out that these are actually fault zones, so they have few segments. However, from the distance, it's not possible to be seen. The next is Kampesteindalen fault that actually stretches a bit oblique to the Babren fault array and Luvahuften fault, and you find it where actually the red outcrops of Huldberget formation suddenly are not seen anymore. And then if you look at the mountain here from the right perspective, you also see a few meters offset on the layers of tricolor fillet member. However, this fault is dying out before going to minking fillet formation. Next in the line is Luvahuften fault zone. Luvahuften fault zone is quite a complex fault zone. It's formed by many segments and many curved fault blocks. However, as we have seen for Ebbablen fault array, this fault zone actually can be seen here on the slope of this mountain, however, also in the inner parts of each of the valley. And what's interesting, you might not see it that well, but here in Ebbadalen, this fault is shown as a monocline. However, further north, we see this fault shown as a just brittle, quite narrow fault zone. Next to the west is Odelfjellet fault. Odelfjellet fault is forming one of the main faults that form master fault zone. And we see it nicely from the north when it's juxtaposing this big minking fillet formation outcrop against a pre-reefed Billefjorden group. And further to the north, we see that it's actually draping the alluvial fence of Odelfjellet member. There's also a brittle surface here, where we see that the outcrops of Odelfjellet member are truncated, and then on the hanging wall, we see quite inclined layers of mean Kinfeld formation. And this is the image on the geological map. And finally, we have the second main fault forming master fault zone. It's the Billefjorden fault. And we can't see it on the uppermost panorama, however, we see it on this 3D model of Pyramiden Mountain. And this is the fault that actually is boundary between the Devonian outcrops. So there is no reported Devonian to the east of this fault. And remaining Billefjorden group and upper Carboniferous layers that belongs to the Billefjorden Trough. There's one more fault. There's many more faults on the Pyramiden Mountain, but one more which has quite severe impact on the sedimentary layers around, and that's a Pyramiden fault. This fault is exposed in the middle of Pyramiden Mountain, and you see it that it's striking obliquely to the two main faults. So there's north-south striking Billefjorden and Billefjorden faults. However, the Pyramiden fault is oblique to these two. And there's a set of smaller faults that are associated with this fault. So summing up, this is the Billefjorden fault zone, which is formed by two main faults, Billefjorden and Billefjorden fault, Pyramiden fault, and a lot of smaller faults associated with the other faults. And what we know so far is that the Billefjorden fault was mainly active in upper Carboniferous. The same goes for Pyramiden fault. However, the Billefjorden fault is a long-lived fault that earlier has been reverse fault. Then in Carboniferous, it was normal fault with the hanging wall block located to the east. However, we know that during the tertiary compressional event, during formation of fault and thrust belt, this fault and probably a few more fault blocks associated with they were reactivated and they were acting as a reverse fault, and the entire fault zone contributed around 200 meters to the reverse movement and to the basin inversion in this area. And yeah, more or less that was the step one, and this is all materials I have used to prepare this step for you. I hope you enjoyed.